We know that mobile technologies have their day, and this is something that we need to work with, I think, within the TAO community and also ourselves within Moodle and our system. Because technology is with us, and there's a lot can be done with, I think, assessment on the move, and when you can do it, and how you can do it. And so, watch this space. It's something I'm trying to work on at the moment. Now, Black and Williams' work, when they looked at the papers about formative assessment going on in schools, they showed this mean effect size of 0.4 to 0.7. This is a big effect size. But what's going on with computer-based assessment and formative assessment? And this is something I'd like to move on to now. Let's look at this. These are just hot off the press, these findings from our physics department. And here we had, I think, 2,500 students. And they had some courses that they were taken before we introduced the formative assessment with the computers. So we can actually, astrophysics and the relativistic universe are new courses, but we can actually compare with the old ones. So in the formative assessment time, the latest courses, the students did the ICMAs on our system. They also did some tutor-marked assignments, and they used to get marks for that, as well as the final exam. Now this time, you do all this work, but you don't get any marks for it. You still take the exam. So the big question is, what happens when you're not forcing the students to do these activities by giving them marks, and what happens to the exam results? And here, this is the same for the formative assessment. This is the way it was set up. Okay. Now, we had a look at how many attempts at these, what do you do? How many times do you try these things? Do you do these assessments if they're not actually giving you any marks? So we find that as the course goes on, you don't attempt as many, that drops off, and we're not surprised by that. And again with the astronomy. But look at the average marks, and they're holding up, aren't they? They're the same as before. They're more or less the same. And then, but the astronomy, the new course, the marks are better with the formative than with the summative. That's interesting finding. And with the ICMAs, and you as the TAO community would be more interested in those, look, that's impressive. We think that's impressive. When did they take the computer-marked assignments? Well, they did take them before the recommended date. But we can see from this graph that also they are using it for revision as well. Very important. Just before the exam, a big rush. And this is helping them to check out their understanding before they take the test. Now, the retention was so what's the bottom line? The pass rates are coming up to be more or less the same. They're not exactly the same, but we're not unhappy with that. And the retention is fine too for us. So we're very happy with those findings at the moment, and we've only just run this. So what did the physicists say who were running the course? They were worried about just having the formative assessment not being used, towards marks, but it had made much less difference than imagined. And also this takes the pressure off the tutoring side and the feedback that they can give more easily to the student and not spending a lot of time marking. So this is a strategy we think will roll out through the university once we get it right. But we're optimistic about the role of the formative computer-assisted assessment. In Discovering Maths, there were 1,800 students here. It was an introductory module, just launched last February. There are 2 presentations a year, a large number of students on this course. And they have practice quizzes, as well as the summative ICMA. So we're actually testing them on the ICMAs. But you can practice beforehand. And it counts for 12% of the grade, so this isn't being marked by the tutors. You get immediate feedback on the practice, but of course you don't on the summative, because you don't want to tell everybody else what the answers are. So what are the grades? So the grades go down. If you look on the left-hand side, these are the summative ICMAs, but the questions get more difficult as well. But you can see that they did do the practice tests, and the results of the findings are impressive there. The number of attempts, going on, so people are practicing, they are using them. There aren't a lot of unfinalised attempts, but maybe what happened, we found with unfinalised attempts, they then went back to their tutors if they weren't sure, and it opened a dialogue with the tutors about things that were personalised and to their needs. And we got the repeats of the practice quizzes, and you can see average is about 3 to 4 times. And at the end of course survey, and the reason we set it up in this course was not to look at exam grades but increased retention. We're worried about retention on mathematics courses, and we did get the increased retention. So we're very happy at the moment. We're going to see how all these initiatives work before we roll them out across the university, because some of our courses have 10,000 students on them. The thing that we're really struggling with, I think, is collaborative formative assessment that will be online. So what is the point of collaborative working? You need a task that is complicated enough where you need 2 heads are better than 1. Here we've adapted a simulation on global warming. On the left-hand side, you can see the variables that are on a slider and can be moved up and down, and the results of your change to the solar constant or the amount of water, the cloud cover, etc., will result in a graph on the right-hand side. So we change the water, and you can see the change to the global temperature. What we've done is actually built a system where we've yoked people via buddy space. This is a system that joins people up when they're online. You can see a map of where the students are, because not everybody is in the same place. You can see if they're online, and you can start to work together. But what's important about this system is that it's yoked. It's not full screen sharing. All that's changed over the internet is the clicks that are made. So the changes that you've made to your system is sent down the internet, so your partner can actually see exactly the same screen as you have, but without using a lot of bandwidth. Because we've got students in remote areas who don't have the bandwidth that's in the cities. And so you also have a chat box where you can actually talk and discuss and agree about how you're going to solve these rather complex problems with a simulation. I think our biggest challenge as well is free text entry. What are we going to do about free text entry and automatic marking? This is, I think, one of our biggest challenges to our community. And I'm now starting to work with Steve Pullman at Oxford to try and think about ways to give feedback to students about their essays, starting to look at maybe summarization techniques to help them build their essays. So one of the systems I have built, though, that's working is a formative assessment system for free text entry for history students. And it has, of course, it's limited. It's only got causal questions. It can only deal with causality. And it can deal with statistics, because history students look at changes to populations with changes to employment, for example, the Industrial Revolution. It can deal with comprehension of a set text, a small amount of text, and can look at identifying similarities and differences for any given event. And it's Java-based, it's got a web service shell, it's got a Moodle-based question type, so it's within Moodle. It's got a forms-based editing tool for the tutors. So the interface looks something like this, and here I've put in, there's a question, a typical question on the syllabus, to which I've typed in no idea. And you get some feedback. Maybe you're a bit confused by the question. It might be helpful to remember you're not being asked about the causes directly, but why the causes have been so extensively studied. And there's the student answer, and there's the feedback. And what's important here in the feedback, we were very influenced by Carol Dweck's work in the United States. Dweck has shown very clearly that when you give praise or response to students, you must also praise their effort, not just their competence. Because when you praise effort, then students will try more, will try again, and will expose themselves to situations that are challenging. Apparently, and she's done the findings of statistical findings with children at school, and that she's found that children are always praised for being clever, will never put themselves in situations where they're challenged or will no longer be top of the class. And so we are in using this work to influence our feedback. When I asked the tutors about how they mark, that's before I analysed, what was going on in the TMAs. They told me that they were trying to give the students the best possible mark and support they could, always looking for what was right. Now, in some sense that's problematic, and you can't do that if you want to model something in a computer. You've actually got to find what the errors are, and then say, here are the errors, and this is, what we found is wrong, and this is how you're going to put it right. So here, the model underneath open comment, first of all, it's detection of errors. Then it's looking for omissions, and here you can see the way I've tried to put the feedback to influenced by Dweck's work. Then you request clarification, and you look for the inferencing. You check the causality and the causal factors. Now, what was interesting for me, because my background's in science, I actually tried to be a student and answer the questions. And I could only get a C grade. This was frustrating. Can you imagine? Only get a C grade. And then I sat down and did some old knowledge elicitation with the tutor, and I found out what historians do is they do actually identify variables, but they weight those variables, and that's what's important in the argument. And as soon as I knew I could weight the variables, then I could get an A grade. So what I would like on this system, it's not there yet, I'd like rules of the game, a button. Because that's what the rules of the game are in history. And that's what students need to know. Once you know how to tackle a domain, what's expected in a discourse, then I think you can move forward.